Okay, now that you know the basics of how to name carbon chains, I'm going to talk to you about the basics of different types of what we call functional groups. Functional groups are basically stuff on the end that makes them interesting and gives the molecule properties, and it allows molecules to interact with other molecules. It allows them to react with other molecules and sort of dissolve in them at times or not dissolve in them at times. So there's a lot of different types of things that come from these functional groups. So it's important to know the different categories at minimum. So what we're going to see here is we're going to start changing the name a little bit at the very end. So let me first start with alcohols. Alcohol, contrary to what you may have heard about alcohol, there's different types of alcohols. There's lots of different types of alcohols. So when we are trying to name something with an alcohol, which actually means that it has an OH in it, and that's all it really means, is it has an OH somewhere. Naming this would be butane. Take off the E and add OL, so it becomes butanol. Now, it is the case that with these functional groups we need to tell people where they're located. Well, this one is located on this first carbon here, so just like before, it doesn't matter if you put the 1-butanol, it's the same thing as just saying butanol. These can come in rings as well, it's just the functional group is coming off of the ring here. So this would be cyclobutanol, and again, it is coming off of the first carbon. We don't really need to say that, but if you want to, you certainly can. Okay. Those are alcohols. Those have an OH at the very end. We'll come back to that in a minute. Sorry, nope, we won't. We're going to come back to it right now. Forgot about these examples. So here we have 2-propanol. So the propanol is 1, 2, 3 carbons right there. The fact that the OH is coming off of the second carbon, that's the reason why this 2 is there. And over here, this is 3-heptanol. Remember, you can count from this direction or this direction, and you want to give that alcohol the lowest possible number. So we're going to start from this direction and go 1, 2, 3. And that's where the 3, 4, 5, 6, 7, heptan, and then OL is from right there. So heptan's from the fact that it's got 7 carbons. 3 is telling people where that alcohol is located, and the OL says that that is an alcohol. Okay. Next come the world of amines. And I'm going to draw this on a different piece of paper because I didn't right here. So butanamine, the term amine is NH2, connected to something. So what that means is we've got 1, 2, 3, 4 NH2. Now it could be that there's a more complex version of this amine statement that I'm not showing you because we're not going to work on that in this class. So we've got 1, 2, 3, 4, and then amine. Can you have that in the middle of the chain here? Absolutely you can. It could be 1, 2, 3, 4, 5, and let's say we had something here that was an NH2. So there's 5 carbons in that chain. That would make pentan. This NH2 means that it's amine. And it's not on the outside, so we have to number it. 1, 2, 3 counting from this side, 1, 2, 3 counting from that side. It is 3-pentanamine. Okay. Next, carboxylic acids. Carboxylic acids can be confusing sometimes, simply because there's different ways to write it. Carboxylic acid is something that ends in COOH. And the reason why it can be confusing is sometimes it looks like this, and sometimes it looks like that. And sometimes you see it as COOH, or even CO2H. all of these ends here are the same thing. So you do need to practice what does that look like in different versions to be able to see that. Now, alcohols had just the OH. See how this carbon specifically is attached to this oxygen, OH. C is bound to 2 oxygens in H, and that's what that means as well. And here it's just written out that that's carbon, same thing as this, OH. It doesn't matter if it's pointed up, down, sideways. It's the exact same thing. The other thing you have to keep in mind is that this carbon right here counts when you're counting your carbons. So if we're doing like something with a hexane, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, and it has this guy on the end. They have to be at the end of something. We would call that hex and, leave off the E, oic, then a separate word, acid. So this becomes a hexanoic acid, and he counts as number 1 right there. Since these have to be at the end of a chain, you can have them in the middle, but I'm not going to do that to you in this class. So let's just think that those are going to be ones. We don't have to number those probably for the most part. Okay. So 1, 2, 3, 4, 5, 6. Make sure you're counting this one right here when you do that hex. Okay. Now, aldehydes and ketones. Let me show you the big difference between these two. Aldehydes have a C-double-O bond at the end of a chain. Ketones have a C-double-O bond anywhere but the end. Now, the thing is about aldehydes, see how this is really inside this as well, but it doesn't have the OH. And remember, when we didn't have this C-double-O bond and it was just the OH, that was an alcohol. So when you combine the two, it's a carboxylic acid. When it's on the end, there's a C-double-O bond, that is an aldehyde. And we end the term of the word with Al, not to be confused with OL, which is very similar, right? And this is a ketone because the C-double-O bond's in the middle of the chain, and we end that with an ONE, or own, not one, own. So in this case, this would be specifically 1, 2, 3, 4, 5 carbons. We want to give this the lowest number possible. This would be pentanal. And here, this would be 1, 2, 3, 4, 5. Pentanone. And we need to tell people where this is. And it's going to be in the 3rd position. So like the carboxylic acids, or even more so than the carboxylic acids, these have to be on the end. So you will have 1 as an understood with these aldehydes, period. It doesn't matter if it's on this side or this side, that would still have to be an aldehyde. You do need to number your ketones. So let's consider something like this. Is it possible to have a ring with a C-double-O bond coming out that's an aldehyde? Nope, not possible, because you don't have an end, right? So these have to be ketones. So this would be cyclopentanone. Now that is going to be a number 1 there, though. Okay. And finally, alkyl halides. Alkyl halides have a different prefix to their name. So they have things like iodo. They don't work on the end of the name, they work on the beginning of it. In this case, we're going to tell people, that's an I right there, you can't see, okay? So this would be 2-iodobutane. I love iodo. I think it sounds crazy. I love it for that reason. This is the case with halogens, period. So fluorine, let me grab over here our table. This would be fluoro, chloro, bromo, and iodo groups, and that would come in front of the name. And you just need to tell people where that's located. So 3-fluoropentane is how you would name this. These can certainly be used in rings, and I'm not going to try to give it to you too complicated for this course. Thank you very much.